Hi, today I'm going to talk about the rubbish classifier using artificial intelligence to identify rubbish and give us some feedback so we put our rubbish in the right bin. And this is a project for the Chatswood High School STEM Club. And there's been quite a bit of preparation. So thanks go to the IT department at the Chatswood School and to Steph for organising the installation of the Microsoft Lobe onto the school PCs. So this is not an easy task. We had to evaluate the risks, and it does take time. Okay, so what is artificial intelligence? Well, this video won't go through a academic study, but we'll just give some guidance. And the definition I've got comes from the CSIRO, and it's looking at a range of technologies that converge to solve problems. And there's a specific goal in mind, and the problem has been solved without explicit guidance from a human being. So no mention of computers or software here yet. So it's quite a vague or a general definition. But the CSIRO, they're using artificial intelligence and learning about it in targeted areas. So it's a problem-solving approach. And an example could be improving the early detection of cancer and diagnosis. And also, the CSIRO are working on traffic congestion problems. And the key thing is that it's a combination of various technologies and academic studies, including using mathematics and statistics. And there's an estimated demand, and the CSIRO are predicting that between 32,000 and 161,000 AI specialists will be needed in Australia by 2030. So this may be an area that you may want to consider in your future career, or you may be working with an AI specialist in your profession. So related to AI is machine learning. So you consider machine learning as a subset of AI, and it's about understanding and building methods that use lots and lots of data to perform a set of tasks. So we're going to use sample data, and that becomes our training data. And we then use another set of data called the test data. And when we're happy with that, we've got a machine learning model which is ready to run. And we would use that to make predictions or decisions without explicitly programming to achieve that goal. And on the photo, we're using a neural net, and neural nets are using connections at different layers to improve the accuracy of the machine prediction. So related terms, we'll be using a technology called tiny machine learning. And it's a combination of machine learning with the Internet of Things devices. So it shrinks learning networks to fit on tiny hardware. And there's an example on the right. We've got a Raspberry Pi Pico, and it's going to be loaded with a TensorFlow Lite model of machine learning. So the devices that I'm looking at are the Raspberry Pi, the Raspberry Pi Pico, and the Seed Studio Rio terminal. So some of the other related terms are neural networks, cluster machine learning, and edge machine learning. So we'll talk about some of those later on. So in my career, I've always been interested in using AI, And when I worked for the RTA, now part of the Department of Transport, one of my jobs was to look for climbers on the Sydney Harbour Bridge. Not these ones. These have been paid and they're allowed to climb the bridge. But we were also interested in those other people that illegally climb the bridge. And we used many security cameras, but it was a difficult job just being able to detect climbers with security guards watching lots and lots of TV monitors. The other area that I was interested in, and civil engineers in the RTA wanted to solve a problem of identifying cracks as early as possible. So you might see these cracks on the road, and as a result of lots of recent bad weather and rain, the condition of our roads has deteriorated. And the earlier that we can detect the cracks and fix them up, the safer it will be for motorists. So we don't want to get to a situation like on the bottom, where we've got severe damage to the road. And back in the 1980s, the technology wasn't called artificial intelligence. We were looking at expert systems to try and help us identify cracks. So this problem was solved by a combination of the CSIRO and the RTA back in 1998, where a special truck, like the one that you see here, was fitted with high-speed cameras and powerful lights, and it was able to move at 100 kilometres an hour, and it was able to classify and identify where the cracks on the road were. And GPS was also used to try and locate the data, which would all be fed into a database. I was also interested in traffic congestion. And I had many projects in the Transport Management Centre, including connecting up to 2,500 closed-circuit TV cameras, variable message signs, and traffic signals. And we wanted to use a better way to try and solve and predict traffic congestion problems. And fairly recently, the goal was defined, and it was to try and predict when a traffic build-up would occur, and would it lead to congestion. And so there was some forecasting and some suggestion. So this was not only using classification or the traffic network as a classifier between different modes of congestion and traffic flow, but it was also for control. That is, we were predicting and seeing whether we could use traffic lights to control the traffic flow. Okay, so let's have a look at the rubbish problem at Chatswood High School. So recycling in our school is terrible. And that's a quote from Leo. And the students of the STEM Club have already started working on solving this problem with a game. And some of the games were ported into a small game console using the microbit. And that was the first tool that was used to try and solve this problem. A second tool was to use the simulation program NetLogo. And that was creating a model to see and compare the differences between recyclers and those who didn't recycle, and what the effect in the community would be if you did not recycle. And today we're going to actually look at using artificial intelligence to classify rubbish and providing students with some feedback did they put the rubbish in the right bin? And to do that, we'll use a AI camera, and we'll turn on LEDs, which will identify the right bin. So you can see on the right is my desktop model. So it's a prototype, and it's using both a small computer, the Raspberry Pi, and also LEDs. So we've got two objectives. There's a basic objective for today, and we won't be using the additional electronics for that, but we will be doing that with our stretch goals. So the basic goal is to learn a little bit about machine learning in a practical situation. And later in school, you will be learning the theory behind machine learning and artificial intelligence. We'll also look at some of the simple steps to make a machine learning model, and learning about what the important tools are for artificial intelligence. So you'll need to brush up on your Python programming skills, but not for the first session. We won't be doing any coding. We'll be using a program called Microsoft Lobe, and we'll go through a process that doesn't involve Python or any coding. We'll also be aware of some of the alternatives, and they're from Google and from others. And the term that we'll be using, or the algorithm, is called TensorFlow. And Google have a similar program to Microsoft Lobe called Teachable Machine. And they also create models for tiny machine learning. So is there hardware available for machine learning? Well, Google use clusters of machine learning processes, and every time you do a Google search, translate, or use any of those tools from Google, that's done in special data centers that use clusters of machine learning processes. But there's also processes on the edge, and we'll be looking a little bit at that next week. So considering the amount of calculations that are involved, how do we speed things up? Well, there's two ways. One is that we can use a TPU, or a TensorFlow processor unit. And one example is the Google Coral USB accelerator. And that will give you perhaps 20 times improvement on the speed of making a prediction of what an image might be. And there are others now, more dedicated processors like the Kendrick's K260, and they're used to speed up the process. You could also use a graphical process unit like your graphics card, particularly if you've got a very powerful one. And Nevada, who are the makers of graphic cards, have come up with a product called the Jetson Nano. And I've got one of their computers on a robot, and it's called the JetBot. So this particular robot uses artificial intelligence to do many things, including tracking, following a particular route, getting instructions from the road network, and it can even go and identify rubbish. And it can do that much faster than, say, a Raspberry Pi Model 4. So we're going to build a machine learning model. And we've installed Microsoft Lobe. That's been done already. We're going to identify the rubbish. And we need to also identify the categories of the rubbish. And ideally, these should match the bins that you've got. So if you've got a red bin for general rubbish that's collected by the council. We could use that as a category. Perhaps a green bin for recycling to the compost, and a yellow bin for recycling paper and plastic that can be recycled by others outside. So we're going to collect data, and perhaps that data will be different from home, and my data will be certainly different from the data that you collect at school. And after we do that, we're going to attempt to optimize the model, but that could take time, and that would be one of our stretch goals. And I would like you to give me some feedback, report back and tell us how well your model performed. Okay, the stretch goal, and we may not be able to do that this year because we have to set up a Raspberry Pi, and it will only really work on a more powerful Raspberry Pi, like a Raspberry Pi Model 4. And you can follow the project. It's on Adafruit. So if you go on the internet or use one of the references that I give later, you can learn more about that. You can use the categories in the standard project, but you can change those to suit the conditions in your school yourself. And in this stretch project, we're going to use the Raspberry Pi to identify rubbish, and we'll inform the user using LEDs that identify the correct bin. So that'll give them a bit of feedback. So stretch goal 2, and we're unlikely to be able to do that this year, we'll use a Coral USB accelerator to speed up the whole process. And it'll be interesting to see how much it does that. Okay, so we'll talk about the images that you collect, the data set, the model, and how we set up our Raspberry Pi. So to get the images, there's a few ways of doing it. One is that we can collect our own images by scraping images from the web using a snip and stretch program. It's advisable to reduce the image size, particularly if you're going to start playing with large data sets. Otherwise, it'll slow down the whole process. You can collect the images with a mobile phone or a digital camera. Now, the images that you collect can be used to create the model and also to test the model. But we're going to use a slightly different approach, considering we don't have much time. And next week, we'll do the full run using this model, which has already been set up for us on a website called Kaggle. And they have a collection of garbage images, about 2,500 in 6 categories. And we'll use that next week. But we'll actually use a subset of that just to get the process going this week. So instead of, say, 393 images for cardboard, we'll only use 50. So we'll use the first 50 of each of these categories to train our model. And I've collected other models, but we won't use those. And so there's one garbage collection. There is another one that has 12 classes of garbage. And in an industrial setting, you might want to sort the plastic and the green bottles and so on. And this particular sorting model has over 15,000 images. And it's available for you to use, but it does take time to train the model, and we certainly can't do it in a STEM club session. Okay, so we're going to use 6 classes, and the tool that we'll use is Lobe. And we'll also code it with these colors. And these colors can be used for our LEDs in the stretch model. And I've also attempted to train a different model with 12 categories with the 15,000. And it certainly takes a long time to get that fully trained. So the instructions on the Raspberry Pi, this is a summary, and you can get those from the Adafruit website. So the way that I've named my model, I give the model that we'll be using next week a GK6MPI. The PI stands for Pi, or Raspberry Pi, the G for garbage, the K where it came from. K6 is 6 classes from the Kangol set. And it's a good idea to make sure that you use a coding scheme for your data set so you don't confuse those. So we'll go through what the objectives, what hardware I'm using, the design, the software on the PC, the Raspberry Pi. We'll look at the results, some of the issues, and some of the references. So it's a good idea to learn some of the steps behind it. And I'm only going to use about 3 steps, but Google recommends 7 steps that you should go through for machine learning. And I've got the references of a Google tutorial on that. Okay, so we'll go on to the next step, collect the data, and we'll be ready to report. Okay, so there's our stretch goal. But what I'll do is I'll go through and identify the how you install or create that model on Microsoft Lobe. Okay, so for our stretch goal, we'll use a Raspberry Pi and we'll follow the Adafruit project. You can change the categories, and on the Raspberry Pi, we also need to download the Python program. We need to collect the data, identify the rubbish, and give feedback. And 2 methods for feedback. We'll be using the LEDs with different colors for the different categories. And we'll also use text-to-speech to inform the user that they've which bin they should put it in. For the hardware, we'll be using a Windows PC. And for the stretch goal, we'll use the Raspberry Pi Model 3 and the Raspberry Pi camera. And I'll be using version 2 of that. And to give the feedback, I'm using Grove Electronics. And to help with the classification and collecting data, I'm going to use a push button. So there's a combination of electronics and cables, and they all fit nicely on a Raspberry Pi hat called the Grove hat for Raspberry Pi. And in my desktop prototype, I'm mounting everything. So the electronics that you see there has all been mounted on Lego wrappers or Grove Lego wrappers, and they fit nicely on a base plate. And I have also printed labels so you can clearly see on the prototype what each of the electronic modules or Grove modules is. Connecting the hardware. So this is how it all connects together. This is the final project with the Raspberry Pi camera, and we'll go through on how that is constructed. So we start off with a PC, and that'll do the programming, and a Raspberry Pi Model 4, and we add the hat to it. So the sockets on top have both digital, analog, and I2C Grove sockets, and we start populating those with Grove devices. So we've got different color LEDs for our different categories. We've got a Grove push button that can take pictures, and the other devices are all for the classification of the rubbish. And finally, we want a Wi-Fi connection, because we don't want this just to be on the desktop. We may have to put it in the schoolyard, not far from the bins. And to help us collect data, we'll be using the Raspberry Pi camera, and that'll be connected like that. For the software, we've already installed the Microsoft Lobe, and we need to install the dataset. So on the Raspberry Pi, we also need to install Lobe and install the program and create a data link. So the Python program knows which directory to find the data. And finally, I'm going to make it a bit easier by using Node-RED on the Raspberry Pi. And it can be used to test the LEDs, or on the bottom, there's a data flow there that runs the classifier. So it's running the Python program, and I can run that with a one-off, or and that's when I would start the program. And for Node-RED, I'm using some extra nodes there. The Python program is shown here, and how I execute it and get it going. But I'm also using nodes for the text-to-speech, for the camera button, and also for the LEDs. And here are some of the results that I've got. So using a Python program called Thorny Python, I'm able to get an output that shows me that the model that I've got here has identified glass on the bottom with a 62% accuracy. And here are the results on the Raspberry Pi, some of the other classifications: paper on top and cardboard on the bottom. And the results on Node-RED, they give me the classification. So when it gets glass, it's able to tell me it's glass, and sound that out in speech. Okay, so for some of the references, I recommend that you go to the Adafruit website, which is the one on the top there, and they have both a YouTube video and a good project description. And rather than just collecting 2,500 pictures yourself, go to the Kangol garbage classification dataset, and that can speed up your project. But it's much more interesting if you can test the project with your own data and also use it in the school playground. So here are the references for the Adafruit project, for the Kangol dataset, and for the tutorial on the steps, the 7 steps of machine learning. And we didn't do all of these. We only did the first 4. We went up as far as training, and we did some evaluation and testing, but we actually didn't do the final 2 steps. Okay, so my videos are also related to this project, and you can get them on my YouTube name. And to get Lobe, go to the website, and to see how you can set up the model, go to my YouTube video, which goes through a process with the reduced data set to get you going. For a copy of this presentation, go to my Dropbox. And for the data set, here is the Kangol reference. And one of the books I would be interested in getting, this will be delivered to me next week. So I'm looking forward to reading this. And another alternative, instead of using the Microsoft program, is to use some of the resources from Edge Impulse. And the advantage over Microsoft is that Microsoft have only run the model on the Raspberry Pi, but Edge Impulse have actually extended that to quite a number of other systems, and you can get support for those systems on their website. And I'll be following up the Raspberry Pi Pico and also the Seed Studio Wii terminal, and they have a PDF on a complete course on tiny machine learning. Okay, so that's it for now, and we'll see you next week.